Usually when we think about like a massive stadium concert or a live sports broadcast, we picture giant satellite trucks and incredibly heavy cameras.
Right, yeah, the massive physical footprint.
Exactly. We just kind of assume the bigger the event, the bigger the hardware. But today, our mission is to look at the invisible microscopic hero that actually makes all of that possible.
Oh, I love this topic.
Me too. Okay,
Okay.
let's unpack this. We are diving into a technical spec sheet from HDTVSupply for a tiny device called the DVIGear DVI-73451-TX Fiber Optic Transmitter.
Quite a mouthful.
It is. And, I know a $299 transmitter sounds like a really dense topic.
It does sound a bit dry on the surface, honestly.
Right. But it is actually the secret backbone of live events. We're going to decode exactly how converting video into light makes modern media work for you.
Yeah, well, if you look at standard copper video cables, they have one massive undefeated enemy: distance.
Just getting the signal from point A to point B.
Exactly. Try pushing a massive, uncompressed broadcast video signal, known in the industry as 3G-SDI. Try pushing that across a sprawling football stadium over copper wire.
That is a lot of heavy data.
It is. And the electrical signal degrades incredibly fast. The voltage drops, interference creeps in, and, your data just falls apart.
So it's kind of like trying to move millions of commuters down a bumpy, congested local road. The data just can't get there fast enough or clean enough.
That's a perfect way to look at it.
So instead of pushing physical electrical voltage down a heavy wire, this transmitter translates that entire live video feed into microscopic Morse code. I mean, it's essentially firing a laser through a glass tube billions of times a second.
Yeah, and this specific transmitter, it weighs just 1.5 ounces. It uses a 1310 nanometer optical wavelength.
Wait, so what does that actually mean in plain English?
Oh, right. Well, in simple terms, that is a specific color of infrared light optimized specifically for traveling long distances through glass.
Okay, I gotcha.
Yeah, so it pushes data at a massive speed of 2.97 gigabits per second. And that is all over a single strand of fiber optic cable.
A single strand? That is wild.
And because it's light, not electricity, it maintains a flawless, uncompressed signal for up to 1.2 miles.
Wow.
Or, if you use their extended option, over 6 miles.
Over 6 miles of uncompressed gigabit video from a device the size of a USB stick.
But, okay, here is the problem I see with relying on light. Light is incredibly fragile, right?
It definitely can be, yeah.
So if you're running this tiny glass cable through a freezing, muddy football stadium, or like it's getting stepped on under a concert stage, how do you protect that tiny beam from getting distorted?
Well, you put it in a literal metal bunker. I mean, broadcast environments are completely chaotic.
Absolutely.
So the spec sheet actually notes this transmitter is built to survive extreme temperatures. We are talking from negative 40 degrees to 85 degrees Celsius.
Wait, 85 degrees Celsius, that is nearly boiling. Exactly. This means the transmitter can sit inside a sweltering, unventilated broadcast truck in the dead of summer and not drop a single frame of video.
Or, survive being buried in snow at a Winter Olympics broadcast.
Spot on. And because it relies on photons instead of electrons, it has a completely flat RFI and EMI profile.
Right, which stands for radio frequency and electromagnetic interference.
You got it. A normal copper cable acts like a giant antenna, picking up noise from power lines, stage radios, and those massive stadium screens.
Yeah, that horrible buzz you sometimes get.
Exactly. But this fiber transmitter is completely immune to all of that surrounding electrical noise.
Okay, I get the temperature ratings and, avoiding electrical interference makes total sense. But the spec sheet also makes a massive deal out of these specific optical ports, the ST connectors.
Ah, yes, the ST connectors.
Yeah, it says they have twist-locking metal dust covers. And I really have to push back here. I mean, is a tiny speck of dust really going to take down a multi-million-dollar live broadcast? That seems incredibly paranoid.
Well, what's fascinating here is the sheer microscopic scale we're dealing with. We aren't talking about a heavy electrical current just pushing past a piece of dirt.
Right.
We are talking about microscopic pulses of light carrying billions of bits of data every single second. And you are relying entirely on a laser diode firing through a glass fiber that is literally the thickness of a human hair.
Oh, wow. Just a hair?
Yeah. So a single speck of dust acting as a physical roadblock at that connection point, it will scatter the laser light. It completely derails the optical pathway.
Ah, so it's less like plugging in an extension cord and much more like, say, maintaining a high-end camera lens. You have to keep the glass pristine.
Exactly. The hardware has to perfectly seal out the physical elements.
Makes sense.
The twist-locking metal covers ensure that when the cable isn't plugged in, nothing gets in. And when it is plugged in, the lock seals it tight so the light travels completely undisturbed in the dark.
So what does this all mean for you listening? I mean, the next time you're enjoying a flawless live stream or staring up at a massive stadium screen without a single glitch or stutter, remember that pristine image isn't just magically floating through the air.
It takes a lot of hidden work.
It really does. It's being held together by tiny, rugged 1.5-ounce metal boxes, quietly battling the elements and firing data in the dark.
It really changes how you view the infrastructure of the digital world, doesn't it?
Totally.
I mean, we still rely on heavy copper wire for so much of our daily lives, yet the actual heavy lifting of our modern media is already being carried entirely by light.
Which leaves you with this to think about. If a piece of broadcast hardware the size of a pack of chewing gum can seamlessly fire gigabits of video via light across 6 miles of freezing, dusty environments, well, how long until we abandon copper wiring entirely and start running our own everyday personal devices purely on light?